Time to learn about properties of quadrilaterals and parallelograms. So, a quadrilateral, again, hopefully you know, it just means it has four sides. Okay, quad means four. So how would you draw quadrilateral mass? Give me one side, give me another side, give me another side, give me another side. Okay, so I have one side, two sides, three sides, four sides. So we can say M, A, T, H. Okay, again, you could have drawn like a rectangle or square and said M, A, T, H. But basically the most important thing when naming is you can't jump across the shape. So I can't say M, A and put T over here. So M, A, T, H. The sides kind of have to be connected. All right, but that's all we know about a quadrilateral, except we know that the angles are going to equal 360 degrees. So a way to remember that is in a square you've got four 90-degree angles, and 90 times 4 is 360. So triangles equaled 180. Now we're going to be dealing with four-sided shapes that equal 360. Okay? But let's jump into parallelograms, okay, which is a more specific type of quadrilateral. So you've got some properties. So obviously a parallelogram is two pairs of parallel sides. So remember they give us the arrows to mean they're parallel. So the top one's parallel to the bottom one, the right and left side are parallel. So if they give you this picture or tell you, that's how you know it's a parallelogram. Okay, property 1. We know that opposite sides are congruent in a parallelogram. So I know this top side is congruent to the bottom, left is congruent to the right. So if the top side is 10 centimeters, the bottom side is 10 centimeters, okay? We don't necessarily know that these are the same. We just know that if they're opposite, they are the same. All right, property number 2. Opposite angles are congruent. So if I have an angle up here, it is congruent to the angle down here. Okay, notice they're both obtuse angles, just facing a separate way. Again, the angles opposite are going to be the same. So if this is 36, this is 36. Property number 3. Same side interior, remember that from parallel lines? Remember, this is a parallelogram, so we have parallel lines. So we know same side interior are going to equal 180. Again, remember you could call them consecutive interior, and that means the same thing. So these two sides added together equal 180. Same thing over here. If I wanted to call that x, those two sides would equal 180 as well. Same thing here. Those two sides would equal 180. Okay, so basically the two sides of the parallelogram are going to equal 180 degrees because we've got a line. All right, last property is the diagonals are going to bisect each other, and this is probably the trickiest of the two. So if you draw a line connecting the two sides or angles opposite each other, this angle right here is going to cut in half the other diagonal. Same thing here, this diagonal is going to chop in half your other diagonal. So I got a mark here and a mark here. Now I don't know that this mark is the same as this mark, which is why I've got two separate ones. Okay, but the diagonals are going to bisect each other. Right? So those are the four properties of parallelograms that you will have to know and memorize because they are true in everything that is a parallelogram that we'll be using all week. Okay? So, joke time. All right, Dad, it's so cold in here. Go stand in the corner. Why? The corner's 90 degrees. Ha 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 ha. Also, I like to think outside the quadrilateral parallelogram, aka box. Are you laughing right now? Great. If not, sorry. Okay. Moving on. Obviously, we're going to get to that part of geometry where you love the algebra part. Okay? So, what's the measure of angle S? Well, I know that's 34. So I know S is going to be 34. Okay? So angle S equals 34 degrees. How do I know that? Opposite angles are congruent. Sound good? Awesome. What's the measure of angle T? Well, here it is. I know those are same side interior. So I need to do x plus 84 equals 180. Or you could just do 180 minus 84 and get 96. So angle T would be 96 degrees. And your justification, the same side interior equal 180 degrees. Okay? So hopefully those two aren't bad because we've done parallel lines before. All right? They do get a little bit harder. Okay, so what is the value of x? So I need to know the vocab word for these two, which would be same side interior equaled 180. So I need to set up a lovely equation. 39x plus 2 plus 100 equals 180. So once you combine like terms and subtract 1 over 2, woo, 78 equals 39x. Divide by 39. And x is going to equal 2. Okay? I am done because it wanted me to solve for x. Alright? If I wanted you to find an angle, you would just plug it back in. Alright, why don't you try these two on your own? Press pause and we will go over the answer. Hopefully you didn't get tripped up with your variables on both sides equation. They're opposite angles, so you're going to set them equal. Again, subtract x to one side, and then you got a two-step equation, and you get x equals 8. Notice it wants you to find the angle r, so you're going to plug in 8 back into this r equation, and then get 135 degrees. Okay, you could double check it and plug it into t, and make sure you got them both to equal 135 degrees. The last one, a little bit trickier, because you had to find the measure of angle F, and then you had to find the measure of angle G. Okay, so again, opposite angles are congruent, so set them equal. Subtract x, add 2, get 6. So I had to plug it back into either one of these, doesn't matter. But when you plug it back in, you get 46 for this measurement and 46 for this measurement. So to find angle G, you had to use same side interior equaled 180, and do 180 minus 46 to get 134 degrees, okay? So that is how you deal with some angles. But now we're going to look at some sides, okay? So let me know if you have any questions with angles, okay? So notice we've got some sides because they're on the outside. Angles are going to be on the inside with the degree mark. Sides are on the outside with no degree mark, okay? In a parallelogram, I know they're equal. So all you have to do is set 2x plus 15 equal to 15. And you get 2x equals 0. Don't stop. Divide by 2. X equals 0. Okay? If I plugged it back in, it would be correct. And so my justification is opposite sides are congruent. So if you get sides, just set them equal. Alright, a little bit of a trickier angle problem, okay? So find the missing angle. Notice they split this one up together. But I still know that all of C and all of D added together equal 180 degrees, okay? So I'm going to say x plus 25 plus 116 is going to equal 180 degrees, okay? So when you subtract those both from 180, you would get x equals 39. So this little measurement right here would be 39 degrees. Again, you can double check it and add them all together and make sure they equal 180. And they do. Okay, so my justification would be same side, interior equaled 180 degrees. Okay, again, you try this bottom one. It's not any harder than the one above it. You just have to do a little bit more algebra. So press pause and we'll go over it. So you had same side interior angles on the bottom, compromising E and D. When you add them all together and set them equal to 180, you would end up getting x is 3. It didn't want me to find an angle measurement, so I was done. Alright, so last but not least, we have the diagonals, and they're probably the trickiest, just because diagonals are funky. So we need to kind of make some marks first. So I know that this part and this diagonal are congruent. I know that that diagonal and that diagonal are congruent. So if you want to draw that every time, it might help you out. Okay, so BY, so this little piece right here is 19.3. So the first thing I need to do is label it. Okay, now it wants me to find BD, which is the whole entire length of that diagonal. Okay, but I know if BY is 19.3, then so is DY. Okay, so then the whole angle is just 19.3 plus 19.3, okay? Or 19.3 times 2. So the whole angle is going to be 38.6 for that whole diagonal. Okay? My reasoning would be the diagonals bisect each other. Okay? So that's one kind of a diagonal problem. Again, on this one down here, first I'm going to label. So the whole entire diagonal was 22. And this piece right here was 2x plus 5. Okay? So again, I know that this piece is congruent to this piece. So there's two kind of ways you could solve it. You could say that this equation is also 2x plus 5. So you could say 2x plus 5 plus 2x plus 5 equals 22. And you could solve it that way. Another way, though, which is probably quicker, if you know the whole diagonal is 22, half of 22 is going to be 11. So this little piece should equal 11. So 2x plus 5 equals 11. And then you have a whole lot of a quicker equation to solve. So x would equal 3. Okay? So again, if we did that up here, we'd have 4x plus 10 equals 22. We would subtract 10 and get 4x equals 12. Divide by 4. We get the same thing. Okay? So it's totally up to you how you solve it. Again, if you know the whole part of a diagonal, you can cut it in half to tell you what this piece is. Now that only works when you have a number right here and not an equation. Okay? So justification would be the exact same thing from up here. Diagonals are going to bisect each other, and I'm going to cheat and totally write it down there. Okay? So those are the properties of parallelograms. Let me know if you have any questions. But there is some practice on it, so thank you for watching.